Hello, I'm Evan, and this is my final project for CS211, Data Privacy. For my final project, I implemented MWEM, which is multiplicative weight with exponential mechanism. And this algorithm was described by Hart, Lingett, and McSherry in a paper on ArcSiv. The goal is to start with a bad synthetic data set and then make it better by improving the results of a set of queries. So first we want to utilize the exponential mechanism to find the most impactful queries to optimize. Then we update the dataset to reduce the error of that query. Before we begin, there's a minor difference between how query was defined in the paper and how the query is defined in class thus far. In the paper, a query is a function from a single record to a real number. For example, if we're operating on the ages in the adults dataset, a query would take in at something like age 5 or age 6 and then output a number like 1 or 0. We can run a query on a dataset by summing its results over each element of the dataset, so we can still have dataset-wide queries, but they can't depend on the number of datasets. They have to depend the number of records. They have to be linear. There's also an additional requirement by the paper, which is that their outputs have to be in the range -1 to 1. Which is equivalent to the queries having sensitivity 1. An example would be a range query over ages, returns 1 if the age is within the interval we're looking at, 0 otherwise. If you do the sum, it will return 1 for each age, and then you multiply that by the number of people that are age, say 5, and it will return 0 everywhere else, and so you ignore those. So it does what we want out of a range query. There are 4 required parameters and 1 optional parameter for this algorithm. There's the data set we want to approximate. This is our non-DP target database. There's the set of queries. There is epsilon, and then there's the number of iterations we're going to be repeating this process because it is an iterative process. And then there's the optional one, which is the starting synthetic data set. If you already have a DP dataset we want to improve, we can input it. Otherwise, it's just going to create a constant one in order to get started. The actual algorithm starts by getting the number of records in the database. If we don't have a synthetic a synthetic database already, we have to make sure that we add some noise to this. My solution uses 1/10 of our total privacy budget here in order to make sure that we have a differentially private number of records. If we don't do that, there is a data leak because people will be exposed to some of the number of records in our final data set and get the true number of records in our database, which obviously violates differential privacy. And if we don't have if we have a data set, we can just use that because it's very differentially private, and so by post-processing, we're fine with counting up this number of records. If we don't have that, we use that number to create a uniform distribution over all possible records, and then we scale it up by n times in order to get the right number of records in our synthetic representation. Then we're going to enter the main loop. And so each time we go through the loop, we're going to use exponential mechanism to sample a query from our entire set. We're going to be using up epsilon over 2t, and epsilon perhaps is reduced there if we had to spend some of it on n. And we're going to use a square function that just takes the raw error between our current dataset and our target dataset. So we're going to choose the worst query out of the bunch. Then we're going to measure it, use the Laplace mechanism in order to make sure that's differentially private. And then we're going to re-weight our data set. We're going to multiply all the stuff in our data set, all of our records, by e to the power of the result of running the query on that specific record rather than a data set, times the difference between the difference of our kind of global error, and we're going to divide all that by 2n. and that's going to probably be too large or too small. So we're going to then rescale that to have the proper number of records using n.